Have you ever stopped to wonder if there's a hidden pattern inside of pure chaos? Well, today we're going to look at a deceptively simple little machine that shows us just that, an incredible order hiding within what looks like total randomness. Just look at this. You have hundreds, maybe thousands of tiny beads, and each one is falling completely at random. And yet, somehow, they create this perfect, elegant, and predictable curve. I mean, it seems like it should be impossible, right? So how does this happen? How does all that chaos turn into something so beautiful and orderly? Okay, so what is this thing? This amazing device is called a Galton board. And while it might look like some kind of magic trick, it's actually a machine with one single brilliant purpose: to take a really abstract idea, like probability, and make it something we can actually see, something tangible. To really understand that beautiful final pattern, we have to start small. We've got to follow the journey of just one single bead as it plays this game of chance. So let's zoom in and follow just one of these little guys on its trip down. As it falls, it starts hitting a whole series of pegs. Now, its path might look totally random, but every single bounce it makes is actually governed by one incredibly simple rule. And every single peg it hits, the bead faces a choice, a really simple one. It can bounce to the left, or it can bounce to the right. That's it. A 50-50 chance, repeated over and over and over again. And you know, this simple 50-50 choice is exactly the same, mathematically speaking, as flipping a coin. Bouncing left is like getting tails. Bouncing right is like getting heads. So, a bead's journey through 10 rows of pegs, that's just like flipping a coin 10 times in a row. Every path to the bottom is just a unique sequence of heads and tails. So, that's what happens with one bead. But what happens when we scale this up? Let's take a look at how all these simple little choices add up to predict the behavior of thousands. Now, if you look really closely at some of these boards, you'll see tiny numbers etched right onto the pegs. And those aren't just for looks. Each number is telling you something crucial. It's the exact number of different paths a bead can take to get to that one spot. This pattern actually has a name you might have heard of. It's Pascal's triangle. And all of this leads to the final result. That beautiful curve that all those beads form has a name. It's called the binomial distribution. You've probably heard it called the bell curve. What it shows us is that while any single bead's path is random, the overall distribution is incredibly predictable. Most of the beads end up right in the middle. And for a simple reason, there are just way more paths that lead there. And the amazing part is, we don't even have to guess. We can actually calculate this stuff. There's a branch of math called combinatorics, which is basically just the art of counting possibilities. And it lets us predict exactly how many paths lead it to each slot at the bottom. Think about it. For a bead to land way off on the edge, it has to make almost all left turns or all right turns. And there's only one way to do that. But to land in the middle, well, it needs a good mix of lefts and rights. And there are dozens, sometimes hundreds, of different paths that get it there. It's the math that brings the machine to life. Now, the theory is one thing, but you know the real magic happens when you get your hands dirty. And these designs are basically an open invitation to do just that. You know, thanks to things like 3D printing and maker communities online, these amazing tools for thought are easier to get a hold of than ever before. The person who created these specific designs has uploaded a whole bunch of different models, from little ones to big complex ones, just encouraging everyone to print their own and start exploring. And check this out. This is a particularly clever design. It's actually made to screw directly onto a standard water bottle. This simple little hack creates a continuous flow, which turns a quick demo into this mesmerizing, endless display of probability in action. It's just brilliant. But it turns out what you put inside really matters. The creator points out that you kind of have to think like a scientist here. For instance, mung beans work great, but flax seeds, they can generate static electricity and just cling to the sides. And fine sand flows so differently that it actually required a completely new design with narrower gaps to even work at all. And really, this is the core message. The designer's own words encourage us not just to repeat the experiment, but to go beyond it, to play, to ask, what if? What happens if you try a liquid? Or something that isn't even a solid or liquid, like oobleck. The whole point is to discover something new through just having fun. So, where does all this leave us? What's the big idea to take away from playing with all these beads and beans? The Galton board, in all its wonderful 3D printed forms, is fantastic. But it's not the end of the story. It's really just a starting block. Its real power is that it's a bridge.
It connects that abstract world of formulas on a blackboard to something you can hold, see, and touch. It's a way to build a real intuition for how the predictive power of math actually works in the world around us.
So if we boil it all down, what are the big takeaways here? First, that a whole bunch of simple, random choices can actually create a predictable and beautiful order. Second, that math isn't just something for textbooks, it's a field for hands-on creativity. And finally, that these physical models are just incredibly powerful tools for thinking. And that leaves us with one final question to think about. If something like probability theory can look this beautiful when we see it in action, what other elegant mathematical truths are hiding all around us, just waiting for us to notice?